Okay, hello folks. This is the lesson for Tuesday, April 14th. It should have been posted at about 8 a.m. and the answers to the practice will go up at 3 p.m. today. I do encourage you to try the practice though before you check the answers that go up at 3 o'clock. So as always, I want to start with the first 5-minute question. So I've given you a table of values. It's a nice straight up, easy one, no negatives or anything, just to make sure you understand the gist of what's going on. And it says, determine if the table below represents a linear relationship. So I would like you to do that. Use the stuff from last time. Take a look back at any notes you've made at the handouts. If you want to go back over a lesson, you can do that. I would like you to try that though, so please try it and pause now. Okay, so to determine if a relationship is, or if a table is linear, we look at the first differences. I'm going to abbreviate that FD for first differences. And remember, the way we do that is we do the bottom number minus the number above. So 10 minus 5 is going to be 5. The next one is going to be 15 minus 10 equals 5. And you may be tempted right now to say, yes, it's linear. The first differences are the same. But it's important that you check all of them, because sometimes I will put in a number that doesn't follow the same pattern. So I'm just continuing here. The last one, 25 minus 20 is 5. So in this case, all the first differences are the same, so we can say this relationship, or this table, shows a linear relationship because all first differences are the same, or constant, either one. Okay, so there's your first 5-minute question. Now on to today's stuff. Today's stuff is distance time graphs. These aren't too bad, I don't think. I think these are straightforward enough for you. So what I've done here is I've given you a distance time graph, and normally when I give them, I won't have any points on them. But what you'll want to do is you're going to need to look at this, and whenever something changes, so here we have a straight line, and then all of a sudden here it curves. So I'm going to put a point there, because this is sort of like a section of the graph. And then it curves and it curves and it's getting flatter, and then all of a sudden it starts to go down. So this is the next important point. So I'm going to label these sections A, B, and C. Okay, and now we're going to talk about what's happening. So you're going to need to look at a few things here. You're going to need to look at the x-axis and the y-axis, figure out what these represent, and then look at the numbers. So the x-axis represents time. You can see here we start, well, this would be 0, right? If this is 10 and 20 and 30, this has to be 0. So we start at time 0, the beginning, and it looks like all in all this run, so this is the graph of someone's run, takes 30 minutes, because that's when we stop. So now let's think about where they are at any given point. So it says here that this is the distance from home in kilometers. The first important thing to look at here is, where do they start? Well, I'm going to add one more point here, and then I'm going to add one last point at the end. Okay, so what we're going to do for these is we're usually going to talk about where they start in relation to home. So in this case, their distance from home starts way down here, and of course that's going to be 0. So you can say they start 0 kilometers from home, or you could say they start at home. And now we go through the first section A, and it stops here. Okay, and we're going to just say that that's right at this line, just to make things simple. So if that's 1, that's 2. This would be 1.5. So we can say that at the end of section A, they're 1.5 kilometers from home, and we can look down here for the time, and we can see that took them 5 minutes. So in 5 minutes, they went 1.5 kilometers. And then we keep going. At the end of this next section, they're now 2 kilometers from home, and now the time is 20 minutes. But you got to be careful, because I'm going to ask you, what was the total time of this section right here? So think about that. I encourage you to pause that, try it, and then tell me, just try to figure out if you can answer the question, how long did this part, section B, take them, and how far did they travel in section B? So I encourage you to pause, try that, and then come back. So please pause now. Okay, so if you say section B took 20 minutes, that's not correct, because section B didn't start until 5 minutes. So the foolproof way to do this every time is to take this second number, 20, and subtract the starting number, or the starting time for section B, which is 5. And then you would find that this section took 15 minutes. You might notice that subtracting, doing the second value minus the previous, is like first differences, and that is very true. And the next question for section B is, how far did they go in section B? Well, if you say 2 kilometers, that would be wrong, because they were already 1.5 kilometers from home. And so the distance traveled in section B, from there to here, again, you take the higher number, 2, and you subtract the 1.5, and you're going to find out that in section B, they traveled 0.5 kilometers. Now what I would like you to do is the same thing for section C. Figure out the time. So section C, the time it took and the distance that they traveled. So I encourage you to pause it, figure out the time of section C and the distance traveled in section C. So please pause now. All right, so the time, it was 20 minutes when section C started. We can see that here. And it was 30 minutes at the end of section C. So section 3 went from 20 to 30, or 10 minutes. And now the distance, well, at the start of section 3, they were 2 kilometers from home. And at the end of section C, they were 0 kilometers from home. So they actually ran 2 kilometers. Okay, now a few other things we're going to do, and this I don't believe is in your notes for today. This is just sort of preamble before I do the official thing. We're going to do a few things for each section. Okay, and again, remember, this is just the first part, so if you're not totally following yet, just keep watching and just try to take it in. All right, so we're going to sort of break up section A into a few different parts. We're going to do the time, the distance, the speed, this will be tricky, and the direction of travel. Okay, and once you've mastered these 3 things, this is actually going to be pretty easy. So now what I'm going to do, I'm going to copy this and paste it for B, and I'm going to copy it and paste it for C, and then we're going to go through and figure this out. Okay, so for part A, the time, well, if we look back over here, we started at 0 minutes, and section A ends at 5. So 5 minutes is the time. The distance, they started at 0, they ended at 1.5 kilometers. All right, now for the hard part. To do the speed, we actually have to do a little bit of math. So when you think of speed, you probably think of kilometers per hour, maybe meters per second, kilometers per second, kilometers per minute, whatever. That word per is really important because it tells us that we need to divide, and it tells us the order. So we always do the distance divided by the time. So 1.5 divided by 5. And if I go to my calculator, 1.5 divided by 5 is 0.3. So my answer here is 0.3 kilometers per minute. And if you think about that, they're running less than a kilometer in a minute, which I think makes sense. I certainly can't run a kilometer in under a minute. So I'll do less than a kilometer per minute. And now the direction of travel. This will probably be the easiest part, or at least easier than the speed. And this is going to be away from home or towards home. And you can see if they started at 0 and they end up further away, they must be going away from home. Okay, part B. The time we already talked about was 15 minutes. The distance traveled, we said, was 0.5 kilometers. And if I wanted to get the average speed over that time, I would do 0.5 divided by 15, and I would get around 0.033 kilometers per minute. Now, direction of travel. Are they getting closer to home? You can imagine in these graphs, if you want, you can draw a little house down here. Whoa, It's a weird looking roof. So there's their house. It's a really nice house. Now, are they getting closer to this house or further away? Well, you can see they're getting further away. Remember, it's the up and down. So they're going further from home. So again, this is away from home. Now, I encourage you, if you can, try to fill this in, maybe on scrap paper for part C. And if you're going to do that, please pause now. Okay, so the time taken for part C, we started at 20 minutes, we ended at 30, so that's 10 minutes. The distance, they were 2 kilometers away and they got all the way home. So 2 kilometers. And the speed is going to be 2 divided by 10, and 2 divided by 10 is 0.2 kilometers per minute. Okay, 0.2 kilometers per minute. And finally, the direction of travel. So are they getting closer to home or are they getting further away? Well, they started 2 kilometers from home in section C. They ended 0 kilometers from home or at home, so they're going towards home. Okay, so that's it for the preamble for this lesson. Now I'm going to get into the part that is on your handout. And here we go. I'm just going to make sure this matches up, and it does. All right, so distance time graphs display the distance that an object has traveled over time. The independent variable always along the bottom, and that is going to be time. And the dependent is always up the side. It's the y-axis, and it's going to be distance. Remember, you can pause and fill in the gaps. Okay, so now we are going to read this little problem and try and solve it. So John is heading to school one morning. He walks 50 meters from his home in 1 minute before realizing that he forgot his books at home. He walks back home, which also takes 1 minute. He then realizes that he's going to be late for school, so he jogs the full 200 meters to school in another 3 minutes. So we're going to fill in this table first of all, and we always start with time 0. And now let's think about this. At time 0, where's John? So John's heading to school one morning. He walks 50 meters from home in 1 minute. So we can assume he started at home, so his distance from home was 0. Okay, so now 1 minute has gone by. And how far away from home is he? Well, he is 50 meters from home. Before realizing he forgot his books. He walks back home, which takes another 1 minute. Okay, so let's keep making time go forward. We don't want to put a 1 here because that'll be confusing. If he goes back home in another minute, we have to add 1 minute here, and we end up with 2 minutes. Okay, so if he walks back home in that minute, what's his new distance from home? Well, that would be 0 because he's back at home. He then realizes he's going to be late, so he jogs the full 200 meters to school. Okay, so in 3 minutes. So another 3 minutes. So we add 3 to the 2 minutes, and we end up with 5 minutes, and he's now 200 meters from home at school. Okay, so what we're going to do is we're going to graph this, just like we did last week. So I always told you that in a table, the thing on the left is the independent and the thing on the right is the dependent. But when one's on top and one's on the bottom, we just say that this is the left and this is the right. So time is our independent in minutes. And I'm going to say this is distance from home, but I really can't write sideways, so I'm just going to say distance. But remember, it is from home. That's important. So let's create an axis here that makes sense. We'll start at 0 for both of these because we end up at 0. We know that there is a point where it's 0, so I'm going to make this red. So 0, 0. And now let's do a scale. So the time has to go up to 5. So 1, 2, 3, 4, 5. And then you can fill in the rest. 10. Okay. Now this graph would look very differently for you because you would just be here at 0, 0 all the time at home. It's crazy, but it's a lot of home time. All right, now for the distance. The distance goes up to 200. So let's see here. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. But I need to go to 200. So instead of going up by 10s, I'm going to go up by 20s. And you might remember from last week, I've said a few times, this is the hardest part of this stuff, is finding the right scale. So use pencil. Try it. If it doesn't work, try it again. I am going to look at your assignments. Most people hadn't submitted them yet. And you really do need to submit those, because if you don't do those, then the rest of the stuff will be very difficult and I won't know where you're at. So please submit those assignments. And make sure when you do that, if you're interpolating, or sorry, if you're extrapolating, make sure your axis is big enough to fit everything that you're going to need to fit. All right, let's plot the rest of these points. 1 minute, 50. And then 2 minutes, back home. 5 minutes, 200. Okay. Now, you might be wondering, how does this tie in to what we did last week? Well, I'm going to show you right now. We can draw straight lines through these points and have little linear relations all over the place. So here's the graph of this guy. I maybe should have spaced it out more, so I used more of the graph, maybe gone up 1, 2, 3, 4, 5, but this is fine. So here's our graph. It's done. So now it says here, the thick line on the graph represents blank, so the steeper line, the steeper the line, the blank that John travels. So the thick line represents, let's fill this in, something new for today. That's going to represent the speed that this guy's traveling. Okay, now, what does it mean if a line is steeper? So if a line goes up faster, then that means that this guy, John, is traveling faster. Okay? So this is on your handout again. If I can switch over to it somehow here. So here we go. And that's it for the first part. Okay? So I have one more question that I'm going to do with you, where we do everything together. This is just kind of the basic stuff. But what you could do here is you could call these section A, B, and C. And in section A, he travels 50 meters in 1 minute away from home. That's 50 meters per minute if you divide. In section 2, it takes another 1 minute to go 50 meters towards home, 50 meters per minute. And in the last section here, from 2 to 5, so that's going to be 3 minutes, 200 meters. Away from home, right? They're going to school. And in a calculator, I could do 200 divided by 3, and that's going to be 66.66666666, etc. meters per minute. Okay, so let's move on to the last question that I want to do together. And again, you can pause this now if you want and try this on your own. I think a lot of you will find you can do this already. Today's a nice, easy lesson. Okay, so look at the graph and translate the data into the table. So I'm going to put the points on. We always have a start point and an end point. And then the other points are going to be somewhat, where the lines change, where they change direction. And now let's fill it in. So let's do the time first. So this is 0, 2, 5, 8, and ends at 10 minutes. Now we're going to do the distances. So 0, this distance, oof, what do you think? Let's say 120 meters. And then this one here, what do you think? Let's say 30. And then 8. Does that look halfway? That'd be 325. It looks a little higher. Let's say 330 and 330. Okay, and you'll notice there that I was kind of like, oh, it looks about like this. And that's fine. If you want to approximate, that's no problem. Okay, now let's do the hard part. So in section A, we always label them like this, or at least I always do. A, B, C, D. So in section A, how far did this person travel? Susan. Looks like it's Susan. Susan traveled 0 to 120. So that's going to be 120. The time it took? Well, the time is going to be from 0 to 2. So that's 2 minutes. Let's skip the speed and direction for now. Let's do section B. In section B, Susan was 2 minutes in and finished at 5 minutes. So from 2 to 5, we can do 5 minus 2 and get 3 minutes. And the distance from 120 to 30. So if we go into the calculator and we do the second number minus the first number, we're going to get negative 90. Ignore the negative for now, but think about what does that negative tell you? What does the fact that this 90 was negative tell us about the direction she's going? Okay, so it tells us the negative direction, which means that this is towards home. And you can just look at the graph. Right? If the lines are going up and to the right, then it's away from home. Away, away, and then we'll get to D in a minute. So for part C, the time from 5 to 8, 8 minus 5 is 3 minutes. The distance from 30 to 330, 330 minus 30 is 300. And you'll notice it was positive. So that tells us that it was away from home. And then in part D, the time, 8 to 10. 10 minus 8 is 2 minutes. And the distance from here to here is 330 minus 330 is 0. Okay, so that's weird. That's a weird one. Now let's do the speeds. For the speeds, we do distance divided by time. So 120 divided by 2 is 60 meters per minute. 90 divided by 3 is 30 meters per minute. And 300 divided by 3 is 100 meters per minute. Awesome. Okay, and part D. Oh, 0 divided by 2. 0 divided by 2 is 0 meters per minute. Well, that's a weird one. Let's look at that one. Distance from home didn't change. So imagine you're on a walk, and all of a sudden your distance from home doesn't change. Think about what that might mean. Well, it means that you stopped, basically. Okay, so if you stopped, what direction are you traveling? You would just say no direction, or no movement, or whatever. They're stopped there. Maybe they're tying their shoe for 2 minutes, or they're talking to a friend, keeping a distance of 2 meters, of course, to maintain physical distancing, talking to that person for 2 minutes. And that's it. Okay, so we are now through this second part. The third question is an exit question. What I would really, really like is for you to try this exit question on your own, pause the video, and then unpause it. And when you unpause it, I'll have everything filled in. So if you don't pause it, you're just going to see the answers, and then it's going to kind of spoil it, and you're not going to really know where you're at. So please pause and try that question now. Okay, so hopefully you paused it, and I'm going to go through the answers now. I just realized that I didn't get the other part of the question here, so I'm going to steal that. All right, here we go. Here we go. You'll notice I skipped a few slides in there. I've just deemed that not super important, and since we're doing it this distance way, I figured I could skip it. All right, so part A. So part A is here. So I'm going to do what's called a rate triangle for part A here, and I'm going to find the distance traveled, and I'm going to find the time. So the distance traveled goes from 0 to 100, so that's 100. And the time goes from 0 to 1, so that's 1. So 100 over 1 is 100. So the speed here is 100 kilometers per hour. Okay, now are they going towards home or away from home? Away from home. Okay, section B goes from here to here. And so again, to get the distance, I go from 100 to 150, so that's 50. And the time goes from 1 over to 3 minutes, so 3 minus 1 is 2. The speed is going to be 50 over 2, which is 50 divided by 2, so 25 kilometers per hour. And now look at the two lines. Does it make sense so far? The green line is a lot slower, and if you look, it's a lot less steep. So that makes sense. Steeper means faster. The next section, 0 kilometers, right? Their distance didn't change, over 2 minutes. So 0 over 2, 0 divided by 2 is 0 kilometers an hour. It says show calculations, by the way. I'm showing my calculations right here. Part D, from here to here. So I do my little triangle. You can see the triangle here. The distance goes from 150 up to 300. So 300 minus 150 is 150. The time goes from 5 to 7. 7 minus 5 is 2. So 150 divided by 2 is 75. So 75 kilometers an hour. And then part E starts here, goes all the way down here. Okay, so you'll notice my triangle's up here this time. That's just to save space. So we start at 300, we go down to 0. So 0 minus 300 is negative 300. And that negative just tells us that they're going towards home. The time goes from 7 to 10, which is 3. I'm going to ignore the negative. 300 divided by 3 is 100. They're going 100 kilometers an hour. And that negative just told us they're going towards home. Okay, how many kilometers do they drive in total? Hopefully you tried this. This is a really hard question. So what I'm going to do here is I'm going to write up here the distance traveled in each section. So section A was 100. Section B was 50. Section C was 0. Section D, 150 to 300, that was 150. And section D was 300. So that's how much they traveled in each section. So all you have to do is add all those numbers together, and you should get that they traveled in total 600 kilometers. And if you think about it, the furthest they ever got from home was 300, and they ended up back. So 600 makes sense. And where does the trip end? Well, what's their distance from home at the end? It's 0, so it ends at home. Okay, so I have now gone through the first 3 pages of your 5-page handout. Pages 4 and 5 are going to be your homework, your practice. But before I do, I want to take you through one little thing that I did say I was going to skip, but now I realize I can't, and that is these different lines if they're curved. Okay, so you might want to jot this down, or you might just want to try to remember it. If you have a straight line, what that means is uniform speed or constant speed. If you have a flat line, what do you think that means? We've talked about it, you probably already know. That means no movement, they're stopped, whatever. If you have a line that starts and gets steeper and steeper and it curves, well, you can imagine what's happening to the speed if the line gets steeper. The speed is increasing. Okay, so this is a curved line. Now, not all curved lines mean increasing speed. They could also mean decreasing speed. And now let's do a few quick little questions. Okay, so I would like you to pause it and choose whether you think the answer to this is A, B, C, or D. So please pause now. Okay, so all that matters here is whether the line is straight, flat, or curved. It's not flat, so it's not no movement. It's not curved, so it's not increasing or decreasing, which means it must be uniform speed. A lot of people here are going to pick decreasing speed. That's why I put it first. But the speed's not decreasing. Their distance is decreasing, but the speed stays the same. Okay, the second one, please pause and try to answer this question. Please pause now. Okay, so first of all, we see that it's a curved line, so it's not uniform. It's not a flat line, so it's not no movement. So the speed here is either decreasing or increasing. And what you do is you look at how steep the line is at the beginning, and then look how steep it is at the end. So it's really steep at the beginning, not as steep at the end. So if it's really steep, it's going fast. If it's not steep, it's going slow. So it started fast, now it's slow, so it's decreasing. Okay, so there's the exit card again. Here's the practice. I'm going to just take you through number one. So there's 4 graphs here. I want you to pick which graph makes sense. So I started to walk to class, but I realized there was a ghost waiting in the hallway. So I went nervously back to my locker. At my locker, I noticed he had left, so I quickly went at a constant rate to class. So the key to this one is that it says they went back to my locker. So at some point they go back to where they started. So in which one of these graphs do they end up back where they started? Okay, and that is going to be this one. Okay, and that means that this is C. Okay, because you can see they're sort of moving away from the locker. They stop and they go back, and then they go fast all the way to class. Okay, let me do one more with you here. Let me delete that because I want you to come up with your own story. Okay, so I was rushing to get to class as I was being chased by Casper. When I realized I wasn't really being chased, I slowed down a bit. Okay, I slowed down. So this is going to be something that starts fast and then gets slow. So look at the graphs and see when it starts fast, so starts steep, and then becomes less steep. Okay, and hopefully you can see that this is the one here. It starts really steep, really fast, and then they gradually slow down. So that's going to be D. Okay, so what I would like you to do is to fill in the rest of this table here. So we did graph C and D, so come up with a little story for graph A, and come up with a little story for graph B. And then after you've done that, for number 5, I give you a little story. I started walking at a steady, slow, constant rate to my class. And then, realizing I was being followed, I ran the rest of the way at a steady, I'm going to say constant, faster rate. So that's a really easy graph. It just checks your understanding. Again, the answers will be posted at 3 o'clock today. And then finally, the graph below represents 4 segments of Selena's morning walk. So this is your last question, totally on your own. I want you to describe the 4 sections. And it says here, include information about direction, distance, time, and speed. So basically, if you want, whenever you see one of these questions, you can structure it like this. Just this little table here. You can make your own little table, or just say segment A, 120 meters, 2 minutes, 60 meters per minute away from home. So just do that for all 4 of these sections here. A, B, C, D. And if you can do that, you are good with today's stuff. Okay, good luck folks, and don't hesitate to email me if you have any questions.